You cannot feel someone staring at you. That prickle on the back of your neck is not a signal arriving from outside. It is a guess your brain has already made. And when your brain has no good information, it does something strange. It assumes you are being watched. You know the feeling. You are on a train reading, and something makes you look up. Someone across the carriage glances away. You were right. You felt it, except you almost certainly didn't. Because in the last 20 years, researchers have taken that sensation apart, and what they found underneath is far stranger than a sixth sense. Your brain runs a permanent, automatic, unconscious search for eyes. It finds them faster than it finds anything else in the world. It processes them without you, and when the picture is unclear, it defaults to the one answer that kept your ancestors alive. Let's start with why eyes matter so much. Look at almost any other animal on Earth and try to work out where it is looking. It is surprisingly hard. Most primates have dark sclera. The part we call the white of the eye is not white in them. It is pigmented, roughly the same color as the iris, which hides the direction of gaze completely. In 1997, Hiromi Kobayashi and Shiro Kohshima published a study in Nature comparing the eyes of nearly 90 primate species. Human eyes were the outlier. We have the largest exposed sclera relative to eye size of any primate, and ours is bright white. Our eyes are shaped and colored to advertise exactly where we are looking. Think about what that means. Evolution took an organ used for seeing and redesigned it to be seen. There is no benefit to a lone animal in broadcasting its attention. A predator that reveals where it is looking loses the ambush. So why would we do it? The answer, proposed by Michael Tomasello, is called the cooperative eye hypothesis. We became a species that hunts together, builds together, teaches together. And to do that, you need to know what the other person is attending to. A glance became a sentence. Where I look tells you what matters, what is coming, what to pick up, what to run from. The white of your eye is a communication device that grew on your face. But there is a cost. If your eyes broadcast your attention, then everyone else's eyes broadcast theirs. And now the eyes of another creature become the single most important object in your visual world. Eyes pointed at you can mean a friend. They can also mean a predator that has chosen you, or a rival who has made a decision. So the brain built dedicated machinery for it. In the superior temporal sulcus, a fold running along the side of your brain, there are neurons that fire specifically for gaze direction. Not for faces, not for eyes in general, for the direction eyes are pointing. David Parrott recorded from these cells in macaques in the 1980s and found neurons that responded strongly when a face looked straight at the animal, and fell almost silent when the same face turned its eyes away. Same face, same lighting, same distance. The only variable was whether it was being looked at. Now here is where it becomes uncanny. In 2005, a team led by Pegna studied a man known in the literature as patient TN. TN had suffered 2 strokes that destroyed his primary visual cortex on both sides. He was, by every clinical measure, completely blind. He could not see a face. He could not see a hand in front of him. They showed him faces anyway. Some looking directly at him, some looking away. They asked him to guess. He protested that he could not see anything and that guessing was pointless. He guessed above chance. And when they scanned his brain, his amygdala, the structure that handles threat and salience, lit up more strongly for the direct gaze than the averted one. A blind man's brain knew it was being looked at. That tells you something important about where gaze detection lives. It is not sitting in the careful, conscious part of your visual system. It runs on an older, faster road, a subcortical route through the superior colliculus and the pulvinar into the amygdala that reaches the alarm system before the image ever reaches the part of you that sees. Which raises the obvious question. If this system is so fast, so old, so automatic, why isn't the feeling of being stared at real? Because of what happens at the edges. Your gaze detection is extraordinary when the eyes are in front of you. Straight ahead, in good light, you can tell whether someone is looking at your eyes or at your ear, at a distance of several meters. It is one of the most precise judgments the human visual system makes. Move those eyes into your peripheral vision, and it collapses. Your peripheral retina simply does not have the resolution. It can tell you that a person is there. It cannot resolve the position of an iris inside a sclera, 30 degrees off center. The signal that would let you feel a stare from behind or beside you does not exist. There is nothing to detect. And the back of your head, obviously, has no retina at all. So what is producing the feeling? In 2013, Colin, Clifford, and Isabelle Mareschal ran an experiment that answers this beautifully. They showed people faces in conditions where gaze direction was genuinely ambiguous. Visual noise, uncertainty, no clean information. Then they asked a simple question. Is this person looking at you? People said yes. Overwhelmingly, systematically, they said yes. When the information ran out, the brain did not return unknown. It returned, "You are being watched." Clifford described this as a prior, a built-in assumption the brain falls back on. Direct gaze is the default. Uncertainty resolves towards being looked at. Think about why that would be built in. The two possible errors are not equal. Believing you are being watched when you are not costs you a moment of discomfort and a turn of the head. Believing you are not being watched when a predator or a rival or an angry stranger has fixed on you can cost you everything. Nature does not build systems that are accurate. It builds systems that are wrong in the cheaper direction. You are not equipped with a stare detector. You are equipped with a stare assumer. And this is not new knowledge, which is the part people find hardest to believe. In 1898, Edward Titchener, one of the founders of experimental psychology, wrote in the journal Science that his students constantly reported the feeling of being stared at and were certain it was real. He tested it in the laboratory. It failed, every time. He wrote that no scientifically minded psychologist would believe it, and that if it were real, it would overturn everything known about the nervous system. That was over 120 years ago. The experiment has been repeated for a century. It keeps failing, and roughly 2/3 of people still report they can feel it. The most determined modern attempt came from Rupert Sheldrake, who ran large numbers of trials in which one person sat with their back turned, while another either stared or looked away. He reported small positive results. Independent researchers who tightened the design, proper randomization, no feedback between trials, no chance for the starer to give anything away by sound or movement, found the effect vanished. The signal was in the setup, not in the room. There is a second thing worth knowing here, because it makes the illusion stronger. Your sense of being looked at is not a narrow beam. Researchers call it the gaze cone, a window of directions, several degrees wide, that all register as looking at me. It is generous by design. Someone glancing at your shoulder, your hair, the sign above your head, all of it lands inside the cone and reads as direct. So even when you turn and genuinely catch a pair of eyes pointed roughly your way, the evidence is much weaker than it feels. You were probably being looked past, not looked at. So why is the illusion so convincing? Because of the loop you are trapped inside. You feel watched, you turn, and here is the trick. The moment you turn, you become interesting. Motion in the periphery is the strongest trigger the human visual system has. The person near you was probably not looking at you a second ago. Your head turning is what made them look. You catch their eyes moving away from you and read it as them being caught. They were not caught, they were responding. There's also a reason the exchange feels so charged when it happens. Michael Argyle and Janet Dean proposed what they called equilibrium theory. Eye contact and physical distance are traded against each other to keep intimacy at a comfortable level. Stand closer and people look less, move further apart and they look more. It balances. Which is why a stranger holding your gaze for more than about 3 seconds feels like an event. They have broken the equation. Your body reacts before you have decided anything, and that reaction gets folded into the memory as proof that something meaningful just passed between you. Then memory finishes the job. The times you turned and met someone's eyes are vivid, slightly electric, easy to recall. The dozens of times you turned and nobody was there leave no trace at all. You are not keeping score. You are keeping highlights. There's one more layer, and it's the one that changes how the whole thing feels. That prickle on your neck, the tightening of the scalp, the sense of a presence behind you. It's not evidence that someone is there. It's your threat system running a routine check on the space you cannot see. The blind spot behind you is the one direction your enormous forward-facing, detail-hungry visual system cannot cover. Something has to watch it. So a low-level part of your brain models it, guesses at it, and occasionally sends up a flare. The feeling is not perception. It is your body's way of saying, you have no data here, and that itself is worth noticing. And when you know that, the whole sensation reorganizes. The next time your neck prickles in an empty room, nothing supernatural is happening. You are feeling the edge of your own awareness, a species that turned its eyes white so others could read them, and in return became permanently, quietly, unable to stop wondering who is reading yours. You cannot feel someone staring at you, but you can feel the machinery that spent 1,000,000 years making sure you'd never stop checking.